Hello everyone, my name is Anastasia Kokori and I am doing a PhD in the field of exoplanet research, and I'm also working as the Public Engagement Officer for the Center for Space Exochemistry Data in London, where I'm coordinating activities for the Ariel space mission, educational activities and outreach activities. My talk today is about exoplanets in the classroom and how we can use real, authentic data of exoplanets to engage the students in the classroom. So, first of all, this is my presentation outline. I will talk about Ariel and explain what the mission is, then about the ExoClock project and how it is contributing to the Ariel mission, the learning goals for students by engaging with exoplanet research, how you can run an entire project in the class by using real data. And then if you don't have enough time to do an entire project, I will also present a shorter activity, but again by using real data. Let's see the Ariel space mission. Ariel is a European Space Agency mission prepared for launch in 2029. It will be a telescope of 1 meter with a spectrograph in order to investigate 1,000 exoplanet atmospheres. Ariel will try to answer these questions: how the planets form and evolve, what are they made of, and what is the weather there. The mission will use the transit spectroscopy mainly, where as the planet passes in front of the star, we study different wavelengths in order to reveal the chemical composition. Now, think that Ariel will study one planet after the other. We are talking about 1,000 planets. So we are observing them through transits. As you can see here, one transit after the other. And if we have a good, a precise ephemeris of the planet, then everything is fine. But if we reach a planet like here, where we didn't have a very good estimation of the ephemeris of the transit, of the timing of the transit, then that means that we lose information about the transit, but also about the planet in general, since this is our only window at the moment. This is exactly where small telescopes can help. Since these observations are time critical, we can already start observing the planets from now, and with smaller facilities to increase the mission efficiency. In order to prepare the mission in the best way and coordinate the observations for all these planets, we have developed the project which is called ExoClock. What is ExoClock? It is a project, an open project, which is dedicated to monitor the planets and increase the mission efficiency, but also it's an effort to open exoplanet science to diverse communities and facilitate collaborators. So ExoClock is inclusive. It includes professional astronomers, amateurs, university and school students, because we really believe that science is an effort everyone can take part and therefore can contribute. ExoClock is also integrated. In an effort to avoid wasting resources, we integrate data from different like facilities and resources, like from literature, from space telescopes, but also from ground, smaller, medium-sized telescopes coming from amateurs or professionals. In ExoClock, we are a really big community. It's an interactive community where we have monthly meetings, annual meetings where we all meet together, newsletters, and a lot of tools to facilitate the engaging experience. Let's come now into the class and how you can become part of this community and bring ExoClock in the class. Real science, real exoplanet science. Now, depending on the time you can dedicate to that, you can become directly part and contribute to the project with a small telescope and dedicate a few observing hours, or you can do a smaller activity. What students will learn out of this? Students will learn, of course, about exoplanets. They can get inspiration about these words. They can learn how astronomers work in the new space era with the modern tools that we have in exoplanet science, breaking stereotypes about science, because science can be interactive and fun at the same time, but also very collaborative. And finally, better understand things about exoplanets and appreciate our planet, the Earth. How you can participate? You can use a school telescope if you have, or a remote observatory, and then observe an exoplanet by using the resources that we have in our educational platform, which is called exoworldspice.com. This website is available in 6 languages, and you can find guidelines on how to observe an exoplanet, but also on how to analyze it. You will find also available datasets to train your students, or if you don't have access to a telescope, you can directly use these to show and to engage the students with real data. The tool that we use for the analysis is called HOPS. It's really user-friendly, interactive, open, free, and accessible to everyone. And finally, you produce a light gear which looks like this. With our support, with our team, reviewing the data to ensure the high quality, but also an engaging experience for you and your students. And finally, your students will get a certificate of participation after successful completion of the project, as you can see here. And this certificate is very motivating because it's signed both by the principal investigator of the mission, Giovanna Tinetti, and myself, where I'm coordinating the project. If you don't have time to run an entire project, you can use these resources here to do a shorter activity. This is published in the Astro-IAU journal, and what it is the activity about unboxing the size of an exoplanet by using a very famous formula in exoplanets. And actually, the activity includes a dedicated presentation for you to introduce students in exoplanets, and all the tools that you need to run this activity. So you will find out this spreadsheet with a light gear, which is printable, and a ruler. And the goal of the activity is for students to learn how we measure the size of an exoplanet by using this light gear. So then we can infer information about the nature of the planet from this light gear also, because the larger the planet, the more gaseous it is, and the smaller the planet, the more it is likely to be a rocky planet. So we use this formula. The first step is to know the radius of the host star, which is given. And in that case, the light curve is taken from a real exoplanet, WASP-10b. We have the radius of the star. We measure the depth of the light curve, so the students can measure with the ruler that is provided the depth of this light curve. And finally, calculate by using the formula the radius of the planet and compare this radius with other solar system planets. And here it's a good opportunity for students to discuss among themselves with the different teams what they got, what they think about this planet. Is it closer to be a Jupiter? Is it more likely to be a smaller planet or rocky style? Only from the radius. And it can become very interactive also, apart from engaging. And here would like to thank you. All the resources are available on the links that I showed. I will be happy to discuss more, but also support any class activities that you would like to run into exoplanets and participate in a real space mission to Ariel. Thank you.